Hello. KD tree, short for k-dimensional tree, is a space partition data structure for organizing points in a k-dimensional space. KD trees are useful data structure for several applications involving multi-dimensional search key, search range searches, and point clouds, special case for binary space partition trees. So it's like instead of 2D binary tree, you're going in dimension. That's cool. It's a binary tree in which every node is a k-dimensional point.
I mean, binary trees aren't really two-dimensional.
True. But I guess you view them as like a 2D graph.
You would view the KD tree as a 2D graph as well.
Oh, so you can represent it like
It's
a 2D graph?
Yeah.
Okay,
So
we'll get
the
there.
dimensionality is sort of embedded in the nodes themselves rather than the tree.
So how would you draw that? Like if I was to get out.
Each
I got
node
this.
would have the axis that it's working on and the position on the axis.
Each node would have the axis. So give me an example.
Actually, it would be for n-dimensional. It has to subdivide the space into two halves, and so I guess it would define a.
So you still have a root? Is that true?
I guess it would define which dimension it's splitting, like split the x dimension. Yeah, it has a root.
Yep.
Yeah, so it'd be like x and then 12. And so it means like everything less than x12 is on one side and greater or equal to is on the other side.
X equals 12, did you say?
Yeah. But it's not really equals, it's like x comma 12. X is the dimension,
Oh, yeah.
and then 12 is the x comma. Yeah, the x equal 12 is in there, but like the fact that it's working on x is like its own bit. It could be working on y or z or w or whatever, any one of those dimensions, and it has a value inside that dimension. So you could say x equals 12, but that's probably
What's this number represents, right?
Where it's splitting the space.
And it's correlated to the x dimension?
It's splitting over the x dimension.
How do I move in this thing? To move, I can just hold the mouse wheel. This is a really nice extension. Holy shit.
Extension?
It's a VS Code extension, which is actually a website, but it looks so nice. How do I like erase stuff? What's this bin element? No. This is
Can you select things and delete them?
yes. Nice.
Yeah.
Yeah, like I kind of watched a little bit of it, and they were talking about like a point cloud, and so that kind of makes sense if you had
It's the point clouds, yeah. Detecting where the point closest to this chord.
And I've seen like I've done a little bit of that like with K clustering stuff like that. And yeah, if dimensionality is represented in this 3D graph, then yeah, so you would represent a data structure out of the points in this 3D space.
Yep.
And
representing those points in like a structured way so it's easy to look up who's at what location.
so let's say we had this and it's, y, x, z, and you were going to represent this as a KD tree. So are there properties similar to say like binary tree where you're going to have a predicate and it's an arbitrary predicate based on the
it's pretty much the
dimensions?
same as the binary tree where like one side is less than, one side is greater than, but you alternate dimensions as you go down the tree. So it's almost the same thing. Like a binary tree is a 1D K tree.
When you say
sort of.
alternate dimensions, though, is it like
Yeah,
is there a fixed pattern to that?
there would be a fixed pattern.
So I could
I'm
do
actually not
like,
sure. I don't think it has to be a fixed pattern.
so could I do
Um,
something like everything
could be
that's
anything,
less
really.
than x, less than or equal to 0, and like x greater than 0, and so you get all the points. You know,
Hmm.
let's say there are points here, and so that's already split it into the like this cloud and this cloud.
Yeah.
And
Yeah, you
so
can think of a binary tree as a one-dimensional form of this, where it's just on the number line.
right. So the number of children is arbitrary. Like it's not going to
Yeah,
be fixed to like a
that that
certain.
that x0, like you pick 0 such that it splits everything in equal proportions.
Well, not necessarily. You don't know how many points are less than
When you
0, right?
construct this tree, that's what you try to do.
Oh, to make it balance or something.
Yeah, you want to make it balanced. Each
Like what?
side is equal number
So
of things inside it.
are those the properties of a KD tree, like balancedness and stuff?
That's when it's most optimal.
What kind of solution are you trying to solve there?
It's like imagine the binary tree and you're doing a lookup and it was completely unbalanced, like it's all on the left.
Yeah,
It's
it
not
would
very
be.
useful. It's the same kind of thing.
So you would do this for searching then? Like I want to
Yeah,
find this.
searching is to find a point that's closest to a certain coordinate.
Okay.
At least that's the example he was giving. I wonder if it could be used for more complicated things.
Hmm. Well, thanks for the general gist of it.
Yeah.
So some key terms. Well, yeah, hyperplane, that's very abstract. But half spaces. So when you split two sides, they become half spaces. And that's kind of like vector spaces. You could almost like
Yeah,
make it
it's
akin to that.
vector spaces. Yeah.
Points to the left of this hyperplane are represented by the left subtree of that node, and points to the right of the hyperplane are represented by the right subtree. Hyperplane direction. I wonder if you could do like red black algorithms on this. Is there like red black KD trees?
I
Does
think
that even make
they're
sense?
very different concepts, and you'll get something very different.
Yeah, but I wonder if it's such a general algorithm that you could apply it to something like.
No, I don't think so. They're
Because,
not that general. These are specific
well,
things.
if you break it down, like I wonder if you could do things like rotation and stuff. If, say, you have an odd trait, I'm going to use that word, such that, you
Yeah, I
know,
think you could do rotation, just like in a binary tree, you can do rotation. So actually, so yeah, there's some similarities, given
but
that.
they would have to have certain properties like ordinality and stuff like that, right?
Oh yeah, yeah, all of this stuff needs ordinality. You can't. Yeah, you can't have a binary tree search space without ordinality.
Oh, so there it does constrain it to the binary nature of things, right?
Yeah,
So
it's
it's
a
always
binary tree.
gonna,
It's
yeah,
a
so
binary tree
it's always gonna split like this.
into two. Yeah, and
But
each side is a less than and a greater than something.
yeah, but their yeah, they're like
Yeah,
points
instead of
rather
just a
than,
number, it's like
yeah.
a hyperplane or whatever.
And so you kind of like say, oh, it's in this cloud of numbers or whatever you're
Yeah,
representing.
each subtree is a separate subdivision of the whole.
I wonder if this could be used like, I mean, we kind of touched on this with collision detection, right? Like when you do quad trees, you're kind of doing that.
Hmm.
So is this like a more abstract like form of it?
No, I think it's just a different form. I'm not sure actually. Yeah, it's a slightly different take on like a quad tree, but it's very similar. Like they're both subdivided. They're just kind of a quad tree is very. I guess a quad tree is specifically like 2D
Its
space.
shape is very bound to like a rectangular shape, right?
Yeah, yeah. Whereas this KD tree, I mean, we should probably
See if it has
validate
correlations.
what the Wikipedia says with my understanding, but I think each node, like how it picks the hyperplane,
Yep.
yeah, I think each node has its own direction of hyperplane, if that makes sense.
Yeah, I think I know what you mean. Like when you split into the sub, what was the term? Half space.
Yeah,
So you've got two half spaces here.
yeah.
You have to subdivide those
You can
points.
subdivide in a different direction. So the top one could
Yes,
be
but
like
they still have to be ordinal such that it's maybe less than or greater than. Is that what you
yeah,
mean? Yeah.
yeah. So like the
So
root could be like x less
so
than
this
or
could
the
be like
equivalent,
on the Y and this could be on the Z,
and
right?
that can be on the y, that can be on the z. Exactly. Yeah,
And then
yeah,
you could like do X.
yeah. And you keep just changing it. I feel like conventionally you just rotate x y z x y z as you go down.
Yep.
But I don't think there's any reason why you couldn't just pick the most suitable one, the one that
Mm,
splits them most easily or splits them
yeah.
most evenly.
And it sounds like there's like sub algorithms just in like how you choose these. Like maybe
Yeah,
you're
he didn't really cover that. It was more like once you've got the tree, this is how you query it. But as for building it, that is a bit, yeah, it didn't go over the best way.
like we could come up with a scenario where it's like here's your 3D space that's restrained to like this cube and like come up with a KD tree where you're subdividing it and you're like creating like a spherical um yeah, you're slowly going from the outside to like the inner, if that makes sense.
Yeah, yeah, you could do that.
And like the result would be, your base case is like you're right in the middle or something, but you're like evenly going. And well, I don't know if that made. I'm sort of speaking too quickly. Yeah, to
Yeah,
verify
you
what's.
could do that. You could do that. It's easier to visualize in 2D, but of course you could do it in 3D as well.
Yeah.
Yeah, they were showing it in a 2D example, and I think that's a lot easier to work with, actually.
Or maybe like another scenario would be like, remember in graphics how we had like the world and it was
Mm-hmm.
made up of like these map height planes. Sorry, height maps. Is that the
Where
right word? Like the is that called a height map?
cube faces and height map. Yeah,
Yeah, and like you just quadrant them into like 4 bits, and then the idea is like how do you connect them? And I wonder if,
it's
say,
the sides of a cube.
yeah, so it's using this, but then it's sort of wrapping in itself, right?
It's yeah, it's subdividing each
Yeah,
face into
so
a grid.
each one of these faces is a height map, right?
Yeah, each face has a grid of points,
Yep.
and initially you just make the distance to the center for every point equal, and that makes it like a sphere.
You
And then
make
after
each the
that,
distance.
you
Sorry,
you apply
say
your
that again.
random number.
No, say that
So,
again.
so take a cube
Yeah.
and like subdivide its faces into a bunch of like into a mesh, and then for every vertex, set their distance to the center to be the same. Your
So
cube will turn into a sphere.
we make a mesh out of triangles, like
Yeah,
uh, so just like we did a flat height map, which was the initial problem,
that
just
height
on
map.
a plane, right? Like that's what we did. I think that
Uh,
was
the height map is sort of a separate step.
yeah,
First,
yeah,
you
yeah.
want to make yeah, then you can apply the height map after that.
So you've got these, say, triangles. Then what?
So you got a big mesh of triangles,
Hmm.
and then you set the distance from the center to be all the same. Set it to some radius.
Oh, yeah, yeah, yeah. I see.
Because right now they've got different distances to the center. The corners are further away than the middle.
Yep.
So if you set them all the same, like that's the definition of a sphere.
And the height is like going perpendicular to the surf. to the plane, right?
Yeah.
So it's just their
Yeah.
distances are
That
all
defines
equal.
the distance to the center.
Mm.
Which is technically not perpendicular to the plane. The plane's
The
yeah,
plane's gonna
they're
like
all
start to curve, right? So then you would have to, yeah, because now you're making it the radius. So it's no longer gonna be that. It's gonna be the normal um, to the sphere that you've created.
yeah, yeah. So this like wrapped plane, and it's
Yeah.
perpendicular to that. Yeah.
So without thinking too hard on this, but maybe this is more just like a quad tree, but maybe you could like use this as a querying sort of language um, to try and find, say, like, oh, where's the player, and then, or where's, yeah, like let's say in Factorio you want to, the world was represented like this, right? And you had the problem of like, where's all the iron ores? So maybe you could use something like this to navigate this complex um, data structure, and then just like find all those bits by sort of traversing it. If you could represent it with this sort of predicate kind of logic, I don't know. Yeah, this seems complicated to implement. I guess if I was to implement it, I would break it down into the smaller bits. All right, can you do binary tree? Sure. But then it's like, can you
Have
represent
we done a binary tree yet? I don't
in
think we have.
Rust?
Yeah.
We could start there. Binary tree. Bin. So, what do we know about Rust that we need to know about before we start this? Well, let me answer my own question with one of them, which is Rust and recursive data structures. Why do we need to worry about this? Well, a tree typically would have a recursive data structure because you would have something, akin to like a linked list. Or it is a linked list, maybe. But like, yeah, you would need like an.
It's like a hyperlink list.
Yeah, hyperlink list. Let's go with that. And because Rust is a safe language, unlike C, if you make a data structure called a node, which can have a reference to another node as its child, Rust is not going to like that unless you do something like put it in a place where it can dynamically allocate memory, like the heap. And so it has data structures like box. I guess you could use like RC for this as well. Yeah, all of these smart pointery type data structures. And for other reference, cell, which is non-mutable, and ref cell, which is mutable, and this provides your interior mutability, which allows you to mutate with just a reference to something without having to have the whole mut. And that's using their own sort of locking system or whatever. So that's one sort of preamble. Sorry? Borrow mut? Yeah. So that's the API, right? So if you have a ref cell, you would use the API borrow mut, which gives you a mutable ref. Oh, it doesn't give you a ref. It gives you a ref mut type T, which is different to say a mut T, because then you can use.
Between cell and ref cell? Ref cell has borrow mut, cell only has like set.
Cell has, yeah, you can change the entire thing, but not the interior thing. Like if it's a struct with fields, you could replace it, right, with cell.
Mm-hmm.
So a binary tree would have a root node. Let's just draw one. What do we have with a binary tree? Some data. Some data T. And then you would have this sort of predicate logic where this is less than and this is greater. It could be the other way. It doesn't really matter. And this means that T has to have these operations, which I think is an odd trait that just comes with Rust. And so if T is constrained to odd, we should be able to navigate the tree. The tree will have children, so binary tree has 2 children. And then we could say like there is like a leaf node that ends, and we could use like optional for none if we wanted. And yeah, that would be the end result. And so like the tree operations that we would need a way of inserting a node. We would need a way of deleting a node, updating all the CRUD, and creating. Create from something. And this could be like your as and from trait, maybe. Like if you were coming from like a list, like a heap map, blah, blah, blah. Let's say this is a list or a vector or an array, and convert to this binary tree form, maybe. Or you could just start with like a head node, which is basically deferring to this, doing insert. The other properties, the complexity would be like sums log, because we're like
insert, delete, update, and create.
Create's kind of like redundant because insert is the creation, right?
So there's normally 4. What's missing?
I can only think right now at the top of my head like extension stuff like rotate. No, that's probably like swap.
What's
maybe
the acronym? What's
CRUD.
the acronym to remember it? Yeah.
All right. Create, replace, which is update. Wait, create, update, delete.
Read.
Oh yeah. Yeah. Thanks. Read at a particular, like given a particular like coordinate. Yeah. And how does the coordinates look like in a binary tree? Well, you could go with like the hash map form, like as reading it, right?
Hash map form?
Oh, sorry, the heap form.
Vector.
Huh?
It's a vector. You read at a point.
Oh, so like you give it a vector like an indices, and that represents somewhere in the tree, given like this is the head. Yeah, that's why I'm saying.
No, it represents somewhere in the space, and then you query it, the tree for the point closest to that space.
Oh, sorry, right. So given a x, and then it will say whether you're like what the value is in the tree. Okay, that's interesting. I mean, that's very contextual, right?
The closest point.
Okay, if that's the API, then sure. I mean,
yeah, that's the K tree, or that's what the video was talking about.
Okay, I didn't watch the video, but right. So you have to know like what the I was almost going to use a mathematical term like the domain is, right? Like if it's x is I32, then you need to know the domain of min i32 and max92, and then you just choose one, and then it'll give you. Does it give you a location as well, or just the value? What does it give you?
It would the value or the point is whatever properties it has.
Does it tell you like the level or something? Like, there's heaps of information you can get out of that. Like, not just like a value
the main
in the
thing is
tree.
getting the point. Yeah.
So just get the closest point.
Yeah, closest point.
So if, say, you've got this tree, right? And you've got like, you choose 6 and 7 and 5 are like there. How does it choose? It chooses the closest point in where it is on the tree. So if 6 was here, it would choose that one, or
it chooses the closest point to the input coordinate.
so the
So
input,
what's the input coordinate?
6.
Right, yeah, so it would pick 6.
Oh, sorry, yeah, right. Let's say 6 wasn't there. Let's say, yeah, this was 8, this was 10. How does it choose something?
I guess it chooses arbitrarily one of those points, 7 or 5.
Okay, so it's based on a bias that you already have in place by what direction you go in.
Well, this binary tree doesn't look great because what's the root node value?
Yeah, I was just picking random numbers.
Yeah, each tree has a certain structure. I mean, with one dimension, it's literally just a binary tree.
Yeah. But we want to satisfy that API that you kind of like watched. What else do they say they have? Construction. Yeah, this is starting to go into the plane. And it does mention balanced, which we could apply to a binary tree. Ooh, so
I think insertion, like updating and adding, is not really usually part of this. You just have a big set of points and then you construct the tree out of those points in one go.
Right. I was just going by binary tree generally rather than KD tree when I was thinking about this.
Yeah.
But what do we want to do? Do we want to do
with the binary tree, imagine that you already know all the values to put into it, and you can be a bit more smart about which value is the root node.
Yes, and that would be like averaging and doing all that stuff too. Yeah.
You pick the median every time.
Median, because median represents, what is median again? Oops.
The middle value.
So it's based on like
median finding algorithm. Oh, yeah.
So median would be like the middle index rather than like the middle value.
Yeah, not average, because average can be skewed by outliers. Yeah, middle index. Yeah.
Yep.
Yeah, mid.
So we could like come up with a binary tree where we have all the values. That's our scenario. Create a binary tree.
The KD tree is pretty much the same as the binary tree, except you keep alternating on which dimension you're comparing. Like first you all sort it all and find a median in X, and then next layer you'll do it again, but for Y, and just keep splitting on different axes.
So how can we like create this binary tree and then coerce it into a KD tree if we've created the right structure? So would we
always be doing it on X?
We would always be doing it on X, but we want to create the API such that it could replace X with something else.
Okay.
And maybe that would fulfill the API for a KD tree if you had like data now that was represented by XYZ as opposed to just X. So we would
So
create
the
like
API that I understand is like given a list of points, create a tree. That's one.
mm-hmm.
And then the other is given a tree and a point, return, sorry, given a tree and a coordinate, return the closest point.
And that's the read.
Yeah, so it's just create and read, no mutation.
Okay. So let's just try and do that. So we can start easy. Like, let's just generate a list of points, and we can do that because we remember how to do random, right? Do you remember?
Use, I can't remember.
It's actually in a third-party library, which sucks.
Oh, what?
Yeah.
There's no random?
Nope.
Oh.
Oh no. Do I even have it?
I know a way to generate random is to like
we can have like
get your seed,
yeah,
and you take the sign of the seed.
let's do it.
And then you take the you multiply it by like 1,000,000 and then modulo by like 1,000 or something. And
yeah. We can have your random and then we can just replace it with
taking the tiny digit in a sign.
Is a seed unsigned, signed?
Let's say float.
Okay. 32? 64?
64.
Yep. So what do we do?
So you take sign of that.
Ooh, how do we take sign? Math? Oh, use math? Use what? Russ? Sign math. Trigonometry. Oh no, I don't have my Vim keys. Ah, is it in a standard? Cool. X dot sign. Wow. You do
What?
dot sign.
Interesting.
Oh yeah, it's arrow.
Yes, I don't really like it because
Yeah, it
that's
should be
not how you word it
infix.
in
How do
math.
you do infix sign? Rust.
Well, more like
Here we
free
go.
function sign.
Oh yeah, free function.
Yeah, because when you write math, you don't write it like 5 dot sign. It's not a thing.
Whatever. So, sorry, you take the sign of this seed?
Mm-hmm.
Wait, can we even do this? We should probably test that sign even works. Oh, it's not working because I need to mod rand, and then that will make it visible, I think. Yeah. There we go. So let's just see if this works first. That sucks. My sign of number. And we'll print it. And I'm missing this and another thing, which is the seed. All right, can I actually run this? I don't know if I have to write pub on this, so I guess we'll find out. Rand dot rand. No, I have to write pub. Okay. Never used. What? Why is oh mod it's conflicting with the thing I imported.
Makes sense.
Wait, what? Damn. Do I have to do use random? Yes, I do. Wait. No. How do you do this? Oh. Random. Okay. Use random. Okay, that works. Do I have to write F? No. Cool. We know how to do modules. Hey, look at that. All right. What's your random generator thing?
So it like modulo 1
Mm-hmm.
with that sign, I think.
Okay.
And then does that even work? And then like multiply it by 1,000,000. And that's it.
Cannot
Try
mod.
like,
Huh?
is there dot mod?
Oh, yeah. You can't mod like floats? That
I'll
sucks.
get frac. Yeah, get frac.
This one?
Yeah.
What's that do? The fractional part of a number. The fractional part of a number is the decimal part. So if you're getting the decimal part of sign, it's like all of the decimal parts, and then you're just multiplying it such that you're bumping the so is it gonna give me like if it was like 1.11, I would get 0.11 with frac.
Yes.
Yeah. And then this is complaining because cannot multiply this by an integer. Sure. What? Oh yeah, that's looking a bit better. So you use this as your random thing that you would. So it has to be bound between, like it can't be bigger than 1,000,000 or something.
The output won't be.
It'll always be below.
This is just a really simple implementation of random. It's not very good.
Let's make a, because obviously I can't visualize the output here. So what we could do is we could write a test that does like fuzzy testing, just gives us some like stuff. How do you write tests in Rust like this? Ooh.
Nice.
And then how would I permute that? I guess I could generate, I'll use your thing to generate some random seeds. Now let's use some fixed numbers. So let's go with something really, really big. Let's go with, what was the limits thing? Use max? What? I can't remember. It was like something max. It was like some stood max trait? No. Did I32 max? Yeah, I remember it. So yeah, let's say we were generating integers then. Wait. Well, the seed is a float. The seed is just arbitrary, right? And we're just going to give it random seeds and then multiply it by our number to see, yeah, what it's going to be. But let's just see what seeds we get. So if I just did like random one, and then how do you test this? If I cert equal, is that how you test? Cert equal one and this? No, integer. Okay. What if I did this? And this has to be a float. Yeah, will it tell me what the value is?
Probably. Yeah.
Yeah, so it's a really big number, which is between 0 and a million. So really you want another thing that says what your top is, right?
Yeah.
So the assertion has to be that it's between, it'll never be negative, will it?
Oh, At this point, it needs to get a little bit more complicated because you don't want the max to affect the random generation.
No, you just want some random number, and then you want it to be between a range, right?
It needs to be completely dependent on the seed. It shouldn't be dependent on the max parameter.
Okay.
As in the sequence of random numbers. Like
Right.
yeah, it's something that I would make as a wrapping function. Like given this, you can make a function that now like clamps it to some max value.
Oh yeah, like using a macro or something? Or like another
Using
function?
another function. Yeah.
Okay, so you would just, so is that a fixed constant, this million?
Yeah.
Just for the purposes
That
of,
has to be yeah. For the purposes
can you have commas? I do this.
underscore.
Thank you. And then we'll have like, and we'll give it min, which is of type T, which is gonna be odd. How do you do this? Where? Odd? Yeah. Surprised that worked. Oops. And you give it the seed. Yeah.
Why is it templated on P?
Because it could be like a float, could be a integer, right?
What would happen if this? Well, let's keep going, but I think this will not
Well,
work.
I wasn't sure about what you wanted, but I thought that this wrapper function would, you give it like min values of t and max values of t, and it would generate.
Of a F64, because we're all F64s here.
Oh, so the seed has to be the same type?
In order to multiply, yeah.
Right. Okay. Well, I can make it so that it's all consistent, if that works.
Okay.
Oh no.
And
That's a problem.
Hmm.
Is there a way such that you could use a float and then based on t, uh, I mean, you would have to match on all of the different types of numbers and like subset them
I
to
don't think
ones
it
that
needs
are,
to be ordered either.
huh? Oh shit.
I don't think it needs to be ordered either.
Well, I was just going by whether t had to be the same of this, so that's why I just copied that. But
So like, hmm, I
it
don't
was
think
only
you'll
because I
do a
thought,
left turn or greater than companion comparison.
yeah, it doesn't need comparison, but I just thought you were saying that the
But
seed has to be this.
in the other one, I don't think it'll do a comparison either.
Oh, okay. I only just put that because min max.
Yeah, that doesn't need comparison. That's just a linear transformation.
So what are we doing?
So the P thing, I think, is making things really hard.
Okay, so just keep it with F64 then.
Yeah, to make P work for needs like have a call sign on T.
What's the
And
general?
yeah, the thing you need for T is to be able to multiply T by T, whatever that trait would be.
Ah, like a mole trait or something.
Yeah, and division as well, and addition and subtraction probably arithmetic.
So we're going to be
Not
multiplying t by t in this thing. You
I
just
recommend not having T.
sure, sure. But I don't know what you want to do for the generator. So you
So
got
the
to outline.
generator, so that there's something that's yeah. So you'll call the generator, but this has two pieces of state to retain: the state of the generator and the output. Oh, sorry,
Okay.
this has two things to return here: the state of the generator and the output. So you could potentially output two things here, or
Yep.
you could move the generator state into a struct and keep track of it that way. Do
Okay.
you remember?
Mm-hmm. Yeah, go on.
Unless you want to, so in like JavaScript and C with those random functions, the state of the random generator is a global. So if you want to match those APIs, then you'll have a global state.
Mm.
But if you don't want to do global, then you'll need to create a generator like structure.
Okay. Hmm. Well, global is interesting in itself because what would that mean? Is it a single number?
Can we have mutable globals in Rust? Yeah, it's
Yeah.
just people.
Static. Let static mut or something. Static mut.
Mm,
Is that a thing?
I feel like dynamic is implied here.
Okay. Let mut global. Oh, what is this? A number?
Yeah, F64,
Okay. And this is the state of what?
the generator,
The generator. So
the random
what
number
can you?
generator.
So what does that mean when you're
So you know when you
going to
call
say?
random in like JavaScript or C,
Mm-hmm.
and if you call it a second time, it's different.
Mm-hmm.
That's because state changed. If the state doesn't change, then it wouldn't be different. So this state needs to live somewhere.
So it just
And
keeps the value of the randomly generated state so that it remembers what its
where
previous
it's up
thing
to,
is so it won't conflict, or is it more than that?
so that it will return something different next time.
So it's just for non-collision.
It doesn't guarantee non-collision, but it guarantees that it evolves.
Yeah,
If
but
there's
it's
no
like
state, it won't
it's
change
just
over
single.
time.
I don't know if this is the right term. Single state where it can only check what its current value is, or does it do more than that?
That's that, yeah, just the last value.
Okay.
You could store more than one, but you don't need to.
But I guess I have to initialize it. Expected an item. Yeah, I guess, yeah, if you had it in main, that's fine. Remove mutex. What are you talking about? Lazy static crate. I don't want to use a crate. Want cell. Crate. Sync lazy. Is this another crate? Oh, it's a nightly thing. Do you want to go down any of these?
I'm starting to think Rust doesn't really want you to have global variables.
Well, yeah, so you would have to
surprised we
go down
haven't-
the struct path instead, right?
Yeah, I'm surprised we haven't encountered this until now. Like, yeah, we've never had a mutable global variable before.
So we could either go down, keep going down this path aggressively, or just be like past the struct.
The struct path would be simpler, I think.
Yeah. Okay.
Yeah.
What else would it need?
And you could call it seed, actually.
This is the seed.
No, I mean the field could be called seed.
So this is not correct, this seed, or is it different? Is that just the initial seed, or?
It'll evolve, but it's kind of equivalent. So now we can make an impl for this struct of like generate with a min and a max.
So this thing, where does this live in this whole thing?
Inside generate.
So I could make this a static method on this by just writing. Oh, this is a static method.
You can inside generate.
Oh, okay.
And just use that implementation.
Because it's only used here?
Yeah, let's just have generate with the min and the max. We don't need the other one.
Okay. So you don't supply a seed, or you do?
So we can reassign seed to be the output of this.
Okay. Self. So, this is interesting. So do I use self?
We're going to mutate self.
So it's a mutable reference to self, maybe?
Yeah. Yeah.
Self dot. Oh, I just read self.c equals that. And then, yeah. Do you still pass the seed? Initial seed? No?
The seed is in self.
Oh, it's already self.seed, you mean?
Yeah.
Okay.
And now you can return seed, but scaled so it lives within min and max.
Yep. So we check. So we just
This is a bit of linear algebra.
so you're not just gonna cut it off if it's past min or past max. You want to do something different, right?
Yeah, you want to. I imagine you want to scale it so that the values between min and max are equally likely.
So kind of like,
Otherwise, like
yeah.
things will get clamped to max, and 90% of the values will be max.
So you find the yeah. So like how far left, let's say, which would be like min. Yeah, it is a bit of linear algebra, I guess, if you try to visualize it, because it's like the seed, you want to, oh yeah, it kind of feels like sine distance functions a little bit.
Yeah. It might help to draw this one out on a number line.
Mm-hmm. Oh no.
Yeah.
Hello. Oh, I can use a line function.
Line function.
On this tool. It's got arrow, circle.
Oh, I thought you were talking about a math function.
No. This is a really good tool.
You need to share screen.
Give me a min and give me a max.
2 and 20.
Give me some seed values.
6.
Mm-hmm. Give me another one.
100.
All right. Let's just put that.
Let's say 22. Are there keyboard shortcuts for these tools? It looks like the number keys are.
Yeah, there are. So if it's proportion, then its proportion will apply even when it's inside as well. You still want to scale it, or only like when it's out, when it's past.
What would happen if you went one or the other?
Well, I would say it's always going to be proportioned by this distance and that distance, and I guess what your actual range is for load or something, like your input range. So
not for float. What's the value we can get?
What's the max value we can get?
From our little equation.
Oh, 1,000,000. The magic number.
Yeah.
Not max float.
Yeah.
So this would be our magic and 0. Yeah. So if this is 18, the proportion of this min and max with this is just that divided by magic. And that gives you how proportional it is in the entire input. So if you then calculate this distance against this distance, then
Wait, split on the 6.
yes.
What's the relation between 6 and 18?
The 18 is the distance between min and max.
Okay.
And 6 is the seed value that we got.
Yep.
And we're trying to fit it in between here, proportional to this thing, right? And so I'm not using any linear algebra, I'm just using logic, so I don't know if this is flawed or not.
No, it's I can see it getting to the right place.
So I was gonna say, like, what is this distance for? What is this distance in 16? And if you make it proportional to this in order to fit it in here, that would mean that a distance of 4 would be, if you say multiplied it by this, would give you
Sorry, I think this does have a flaw.
okay.
So which bounds is 6 relative to? What was its min and max possible values?
6? What is the 6's possible min and max values?
Yeah, so it's the 0 in magic, right?
Oh, in terms of what you can generate with the RNG generator?
Yeah.
Yeah.
6 came from that bound.
Oh, so this is the space in here. Actually, I should say 6 is there.
Yes.
Okay, sorry. Oh, okay.
Yeah.
Sorry, yeah. So that's confusing.
Yeah.
That is actually confusing. I did that wrong. Yeah, so it's like transform 6 to this, which means multiply 6 by this in order to situate on this, right? And then if it was, say, so if you got a value that was like 1 and you times it by this, it would bump it into this range.
Almost.
Well,
let's say the random number generated 0.
Oh yeah, that's not good. You times it by the min to get it to, so you have to, like, what's transformation operations? You can translate. So it's kind of like you want to put it like at the center and then do your transformation and then put it back. Do that sort of thing, right? Is that kind of like what you got to do?
Yeah, like that.
So what would be the center? Well, the center would be in this. We want to, like, this is our transformed coordinate system, or is this our, or is this the, or this is this the origin, or is this the So
the bottom one is where you're coming from,
right?
The top one you're going to.
So if to avoid 0, do you have to, like, maybe find the midpoint or something? I don't know, and then use that as like an origin.
Not the midpoint. I mean, it's possible. You could do it like that, but it's more complicated than it
it is. I'm trying to, like, visualize it, and I can kind of see. I'm like almost halfway there with the visualization.
Instead of the midpoint, think of the leftmost point.
0.
Yeah.
So if I put 6 at 0, that would mean I would be translating it this way, right?
Nah, don't put it at 0. It's you'll make your range relative to 0, which it already is, so you don't need to do anything there. But then you do the next step of the other range from 2 to 20. What is its origin?
2.
Yeah.
So this is
You want
equivalent to like
and
this is the 0. This is the
mm,
0 of that range, and this is the magic of that range.
yeah.
And visualizing is hard in this because yeah, so if I just plus 2 there, 6 times magic plus 2. Yeah? Or no?
Yeah.
Because
That's good.
that gave me the proportional on this thing, and then I
Yeah.
just need to translate it up there to
Yeah.
get it. That was harder than I thought. But the
Yeah.
visualization is really nice because it's like, put like, what's this section? And then it's
Yeah.
like, what is it from the true origin, which is this section?
Yeah.
So it's like, go there and yeah, go up. So it is like a linear algebra thing. Yeah, you're right.
I find thinking about the endpoints is really helpful. Like,
Yeah.
say your input is 0.
Yeah.
Like,
Tell me what to
how
draw.
do you
Like,
get 0 to
well,
become 2? Like, you have to add 2
wait,
zeros.
can you actually take charge of my thing? Can you draw it?
No, not through me.
Oh, that sucks.
It'd have to be through remote desktop, which requires installing scary things.
How about um yeah, that sucks. All right, you tell me what to draw.
Yeah.
You tell me
Okay.
what to draw.
Very similar to what you had before. As in, this is how I think about it.
Yep.
Yeah, yeah. So very similar to what you had before with the 2 and the 20.
Mm-hmm. Yep.
And then, yeah, underneath we have the 0 to, let's say, 22.
Mm-hmm.
So, like, physically, if you can imagine just picking up this line and moving it to the right and then squashing it down, there's a certain order in which you have to do that, because you can obviously just add 2 and that'll align it left side to left side.
Yep.
But then you can't squash it without altering the left side. So you have to squash it first. And so you would divide 22. Yeah, you do like, yeah, 18 divided by 22 is your multiplier to make this now the size of the top one, size 18.
Yep. So you'd squash it
And then now that it's
first.
the right size, yeah, now that it's the right size, you can then add, and it'll just bump up to
I'm just
where it
gonna
needs to
do
go.
this as the squash upper. So first squash.
Yeah.
And now it's proportional to that.
Now it's the same size as that, so that right-hand side will be a bit further in.
Mm-hmm.
It won't be aligned.
Yeah, sorry, I didn't intentionally mean that, but yeah, whatever.
It will be further in, it won't be further
Oh,
out.
sorry, right.
It's
Yeah.
going to be the same size as the top line.
Yeah, I'm not doing this proportion. I was just drawing randomly. So.
It really helps to try and draw proportionally.
Okay. Okay. I see.
Otherwise, you'll confuse yourself very easily. You'll see, oh, it's greater than, or I need to keep squashing it or
Okay.
something.
So what if I did
When you
this
work,
as a red
yeah,
line and then do that as a red line?
no, try and keep them physically proportional because you want to make use of your physical brain,
Okay.
the part of your brain that like sees objects and can like work out, can this fit in that hole, and do
Right.
I need to make this bigger or smaller? You're trying to act, at least I use that part of my brain to deal with these problems.
Okay, so what if I copy this and then do that? Is that better?
Yeah. So now it's like equal size and like, oh, how do I get it up there? I just move it to the right.
Mm.
And that's add to.
Yeah, that's really, I mean, it's intuitive when you say it like that. It's not intuitive to go to the steps of that. But yeah, can we have more? Can you think of more problems like that? And I can try and.
So this, if you just remember these steps for this problem, and you will reuse it again and again and again. This is like one of those fundamental, like it's like final minus initial. You just remember it. You just remember that segment of math and where it gets used, and you'll see it pop up everywhere. Like we use final minus initial here to work out the length. 20 minus 2 gives us 18. That gives us that line distance.
That's true. Yeah,
and
you're
and
abstracting
moving
it
from
down to
the
the
y
operation that is a vector operation, which
yeah
you could like remember, but it's like you're remembering the operation that satisfies your visual need to squash and
yeah
to find. So it's out of necessity rather than just, oh, I have to remember finance my initial, which is the real trap in doing those sorts of mathematics. Well, particularly with the way it's taught in high school, it's like remember this, and then you remember it, and then you don't really understand it.
you've got to match it to the intuition so that when the
Yeah.
intuition goes, oh, I would like to solve this problem, you know you've got the math for it, like
So
that you can
I remember you
translate
saying
it to
like a
an
common one you do is like figuring out the Lerp equation or line equation.
and this is it. We
Yeah.
just did it. This is the linear interpolation between two values into another pair of values.
So do you have, I know maybe this is a bit of a stretch, but like a Lerp scenario that we can apply?
Yeah. Let me think.
Or even like the
Yeah,
polygon
I
thing that you
know.
were doing. Oh yeah, sorry, go on. Yeah, you.
So one good scenario is drawing a mini map. So
Okay.
you've got like the world and you've got all these like characters, and you want to draw the world in a mini map,
Yeah.
like on the in the corner of the screen. And
Yeah,
it's
yeah,
like
yeah.
for each object,
Yep.
where in that mini map box do you draw them?
That's
And
a
it's
really
just
good
a
one.
linear interpretation of the big world, the world space into this mini map view space.
Can we try that?
Yeah.
So
So
let's
it's
say,
like 200, 200 or whatever.
oh, whoops. I don't know what these numbers are. I'm just gonna use traditional math. Let's just go with that. 200, 200.
Yep. And let's draw a little mini map in the corner and come up with the coordinates for that.
Yeah, and like to make this, I mean, I could make it easier by making it situate right on this, or let's make it like, yeah, 50, so 150. So that's where it starts, and this is of size. Yeah, it can have a little bit of a buffer, so maybe it's like 170. Oh no, that doesn't work. 160 maybe, and 190. So there's like a 10 width gap.
So draw those numbers on the mini map, like where the
Oh, yep. So,
where the start and the end are in the x and the y.
yep.
That's
So
important.
yeah. So I'm just gonna make it proportional, I guess. Oh, maybe this buffer is going to be a little bit bigger, make it a bit more difficult. So it's like, this is 100, and that's going to be like, what's an even number to use? I don't know. But that's, oh yeah, let's just go 150 again. Yeah, let's just make it the same. And then it's got the buffer. Okay.
Honestly, the numbers don't matter that much.
Okay.
Because like it's all going to turn into equations with variables. It's like the left side is this x coordinates, and we just use that generally, and we can edit those variables as much as we like, and it'll still work.
All right, let me draw it properly then, because it's. Oops. It's still so good. Except when I'm doing this. Can't select everything. Okay.
You could probably have to zoom out to do that.
Yeah. 6. And that's shift works. 6. I don't like the hotkeys. I want to change them. Oh, whoops. Is it? It's X, Y, right?
Yeah.
What happened to binary tree? Oops.
Mm-hmm.
Oh, we were doing binary trees and other stuff.
Yeah. Why are we doing binary tree? We wanted random to generate random values.
Yeah, and we just keep getting distracted to other things. Oh well.
We should be able to wrap around to binary trees. We just need to keep going deeper.
Yeah, just keep going deeper. Exactly. So
We're
you're saying
really close. We got like a coordinate space, and we'll have stuff in it, and we'll need to make a point cloud tree or something.
okay. Here's the mini map.
Yeah. Give it some set out some coordinates for these x, y bounds.
So let's say 150, 190.
Yeah. And you only need to do 2 corners. The rest is sort of implied. Oh, but you can write it if you want.
Okay. 150, 1. I'm just gonna draw the middle because I can't really. 17. No, like 150's there, so it would be like 130 maybe. Yeah.
Wait. Where's 0?
For Y?
Yeah.
Oh wait, 150 is like there. Oh, maybe I'll draw the full quadrant because I can't really. My brain can't do this. I don't know why. And then can I do like dotted lines? Oh, I can.
There's a mild issue in that the thing you drew is a rectangle when the coordinates are a square, but it's fine.
Yeah, I'm not really. I wasn't very accurate. Sorry. That looks really nice though. How good is this tool?
Pretty good.
Okay, so hopefully that helps in terms of what I'm picking, because that's kind of like, yeah, 190, and in terms of this, well, 150 is there, so we'll just make it like 130. Yeah, we'll just flip them. 130, and then this is 130.
Where's 130 on your grid?
130 is So that's 100. That's 150. 130 is there.
Yeah. Sorry, I got confused.
That's all right. I'm trying to do this as well in my.
I was thinking that the middle line was 150. No, it's 100.
No. Yeah, I can write it down if you want. It's clear.
No, that's all right. Right.
Yeah. 190 and 130.
Mm-hmm.
And this is 190 and 190. Yep.
Mm-hmm. Yeah.
So should I draw something?
Yeah, draw a dot somewhere on the canvas, and we can work out where should it go on the minimap.
Whoa.
Give it.
Whoa. This is so cool. Yeah, right. There's our dot.
Yeah.
X marks the circle marks the spot. Whoa, what is going on? I'm changing the background. Interesting. There you go. Yeah, so where's this? This is like 100, and then that's 130. So let's go like with 127 for Y, and then let's go with like 50, 25. So let's just say 23. Yeah.
Yeah.
All right. So let me just see if I can go by what we just did, where I want to put it on somewhere here, right? So if I was to do this, I want to like visualize this square and squash it into that. And so if I was to squash it, well, I would make it proportional to the size that this is. And to do that, I need to know how much to squash this by and this by. So I would find minus one initial of this and get a value, and I would do that. So I'd get like should I use the word vector here? I guess because I said finest minus initial.
Sure.
Because I guess when it comes to 3D graphics, now you're trying to like direction is important, so let's keep that. And then so you get that proportion, which you can then get. You can make this. Huh?
What's that proportion? Like the number?
Oh, what's the number? It would be like the Y final minus the Y initial. So that's 60.
Yeah.
So
So
I'll write
it's not really a proportion, it's like the width or like the height.
the proportion is when you make this proportional to that. So
yeah, I don't know what proportional the proportion means refers to, but yeah, that's the height of the minimap, 60.
Whereas the height of the mini map, the big map or the real world is 100, 200.
Yeah.
So we can squash this accordingly by finding the division of 60 over 200. And that gives us where this line would. So I'll just draw that, I guess. Draw this line, copy there.
Yeah. Yes.
So
And so our like example dot, where would that end up?
well, that would be 60. Oh, sorry, right. This dot or this dot. Oh, this one. Oh, sorry, right. Yeah. So because we got our proportions for the Y, we just have to say what's this dot proportional to this guy. So if I copy this, let's say it's, yeah, it's like kind of here, let's say.
I'll do the math. The calculator says 38.1.
Okay. So I can now copy this guy here, 38.1. I don't know what the x is because we haven't done that yet, so I'll just do the, yeah, it's like around there. 38, like that, maybe?
And the x 23 is 6.9.
6.9. So if that's 25, then that's 12.25. So 6 would be like there.
Pretty cool. Yep.
What was the numbers? 6.9 and 30.
6.9 and 38.
38. Yeah. Okay, so that's kind of that. And then we want to move it there. So to move it there, we can go, what's the distance to move this 0, 0 there, which means move this guy there. And that just means add 130, 130, right?
Yeah.
And so we take all of this and we add it.
Yeah. Nice.
Is that it?
You did exactly what we did before, but now in 2 dimensions at the same time.
Yeah.
Yeah.
Yeah, I know it, like it's logical. It's just like practicing the sequence and then
Yeah, it's just getting that intuition about the physicality of it.
yeah.
That you gotta just do and see and get that part of your brain like activated, which you can't do with words so easily.
Oh, thank you.
Yeah,
Sorry?
this got me through
Victoria.
Right. Okay.
We can come back to this another video.
Yeah, we did a fair bit.
Yeah.
Yeah, you made a nice drawing as well. It's very neat.
Well, it's mainly the tool. It's not me.
Yeah, the tool helps make straight lines.
Well, goodbye, JS Paint.
Nah.
GG.